Hello, everyone. My name is Victoria, and I'm a senior at Florida Gulf Coast University.
My name is Vincent Ciarcia, and so am I. And our project is the Tipsy Cop and Robbers game on graphs. So for our abstract, we studied a variant of the cop and robber game in which they can both be tipsy, meaning that a portion of their moves will be random, and we used a spinner tool to determine who moves next and whether or not that move will be sober or not. And we use the theory of Markov chains to answer questions like, what is the probability that the game will last m rounds if they start distance d away, and what is the expected number of rounds that the game should last if they start distance d away?
So we used a spinner wheel to determine if the next move is a sober cop move or sober robber move or a tipsy move by either player. And if we look at a vertex transitive graph, we can basically combine the tipsy moves under one general tipsy move, and then we have three segments on the graph.
This is just a mock game of the game on paper graphs with 6 nodes. So the start distance d away, and the first move is a tipsy robber move, sober cop move, sober robber, sober cop, sober robber, sober robber again. He elects to stay in the same spot, and then sober cop, tipsy robber, tipsy cop move for the win. That game lasted 10 rounds.
And as you can see from the cycle on 6 nodes, they can be a distance of 3, 2, or 1 away from each other. And based on this game, and we can create a Markov chain that basically shows if they are at distance 0 away, 1 away, 2 away, and 3 away. And distance 0 basically means that game is over. And for given values of C, R, and T, our probabilities of being sober or tipsy, we have the following results. And as you can see, starting at distance 3 away, which is the maximum distance, keeps the game going the longest, and the probability of survival is the highest.
We also analyzed the game on other graphs, friendship graphs in the top left, Pearson graph in the top center, toroidal graph in the top right, and the bottom is an example of an infinite graph, or an infinite path, which we also analyzed the game on. And we also analyzed a variation of the game where the players sober up over time. And some results can be seen in this table in the 4th column, where t is a function of their of time, of where little m is the number of rounds that have passed.
We also looked at the tipsiness as a function of distance. So basically the tipsiness would change. They'll become more tipsy if they're too far away and they get careless, or they'll sober up as they get closer and maybe they can sense each other and the cop tries to catch the robber and the robber tries to escape.
Here's some future directions and open questions regarding this game, the references for our project. And thank you so much.
Thank you.